The human mind, a vast and intricate landscape within each of us, remains one of the most profound mysteries in the universe. For centuries, philosophers, scientists, and thinkers of all kinds have grappled with its complexities, seeking to understand its origins, its functions, and its ultimate potential. Consciousness, that deeply personal and subjective experience of the world around us, feels undeniably real. It's the vibrant tapestry of sensations, emotions, thoughts, and memories that make us who we are. It's the feeling of warmth on your skin, the taste of your favorite food, the joy of a shared laugh, and the sting of heartbreak, yet explaining precisely how this rich inner world arises from the seemingly mundane physical matter of the brain. The intricate network of neurons, synapses, and electrochemical signals remains one of science's greatest and most persistent challenges. How does mere matter give rise to subjective experience? This is the hard problem of consciousness. Could quantum physics, with its bizarre and often counterintuitive principles, that seemingly paradoxical realm of atoms, subatomic particles, and the strange phenomena they exhibit, hold the key to unlocking the secrets of consciousness? Could the answer lie not in the macroscopic structures of the brain, but in the quantum processes occurring at the most fundamental levels of reality? To many, the idea might seem absurd, a leap too far into the realm of speculation. After all, quantum physics governs the behavior of the microscopic world, the realm of atoms and subatomic particles, while our brains, as far as we can tell, are undeniably macroscopic objects, complex biological structures composed of countless cells and intricate networks. However, despite the apparent disconnect in scale, a growing number of scientists and researchers believe there might be a profound and previously unrecognized connection between these two seemingly disparate realms. Could the strange and counterintuitive rules of the quantum world, phenomena like superposition, entanglement, and quantum tunneling, ultimately underpin the very fabric of our thoughts, our feelings, and our subjective experience of reality? It's crucial to emphasize that this is not about quantum mysticism or pseudoscientific speculation. This is about the application of rigorous mathematics, advanced physics, and the pursuit of experimental evidence to explore a potentially revolutionary new understanding of consciousness. It's about searching for a common language, a unifying framework that can bridge the gap between the inner world of our subjective experience, our thoughts, feelings, and perceptions, with the outer world of objective reality, the physical universe that we can measure, observe, and quantify. Join us now on a fascinating and thought-provoking journey to explore the mind-bending possibility, the tantalizing prospect, that the same fundamental mathematical principles, the same underlying laws of physics, might ultimately explain both the vast and complex universe that surrounds us and our own conscious place within it.
The human mind, in its incredible complexity, is a landscape of ever-shifting thoughts and emotions. Ideas spark and fade, feelings surge and subside, creating a dynamic and often unpredictable inner world. Yet, within this constant flux, there exist points of stability, anchors that ground us amidst the storm of daily life. The human mind, too, has its own fixed points. Think of a childhood memory, a moment etched so deeply into your consciousness that it remains vivid and accessible even after years have passed. It's a mental landmark, a familiar place you can return to in your mind's eye. Or consider a core belief, a fundamental principle that guides your actions and shapes your worldview. It's a compass that points you in a consistent direction, providing a sense of purpose and meaning. Perhaps it's a deep-seated fear, an ingrained response to a perceived threat. While fear can be debilitating, it also serves as a powerful anchor, shaping our behavior and influencing our decisions, sometimes without us even realizing it. These are stable patterns of information, neural pathways that have been reinforced through repeated experience and emotional association. They represent the enduring aspects of our identity, the consistent threads that run through the tapestry of our lives. Within the vast network of our neurons, a complex web of interconnected cells that transmit and process information throughout the brain. These connections, forged through learning and experience, create the framework for our thoughts, feelings, and behaviors. Persisting despite the constant flux of thoughts and sensations, the relentless stream of information that bombards our senses every moment of every day. These stable patterns provide a sense of continuity and coherence, allowing us to navigate the ever-changing world around us. Could these fixed points in both the quantum world and our minds be connected? Is there a deeper relationship between the fundamental building blocks of reality and the structure of our consciousness? Could they be governed by the same underlying mathematical principles? Could the equations that describe the behavior of subatomic particles also shed light on the workings of the human mind? These are profound questions that lie at the intersection of physics and psychology.
Quantum physics reveals that our universe is also a sea of change, a realm of constant activity and unpredictable behavior. The quantum world is not a static, fixed entity, but rather a dynamic and ever-evolving system, with particles constantly fluctuating, appearing and disappearing in fleeting moments, their properties uncertain until the moment of observation. This inherent uncertainty is a fundamental aspect of quantum reality. Yet, even in this quantum realm, there are fixed points, stable configurations, and predictable patterns that emerge from the underlying chaos. Stable states that remain constant, defying the constant flux and providing a foundation for the emergence of more complex structures. These states are crucial. They are the bedrock upon which all matter is built, the fundamental building blocks of the universe. They give rise to the properties of atoms and molecules, determining how they interact with each other and shaping the characteristics of the substances they form. Forming the building blocks of our world, from the air we breathe to the ground we walk on, everything is ultimately composed of these stable quantum states.
Imagine a turbulent sea, a vast expanse of water whipped by fierce winds and churning currents. Waves crash, currents shift. It seems chaotic, a maelstrom of unpredictable forces. Yet beneath the surface lie islands unmoved by the turmoil, silent witnesses to the raging storm above. These are fixed points, points of stability in a sea of change, offering refuge and resilience in the face of overwhelming forces. They are the anchors that allow us to weather the storm.
In the quantum world, stability often arises from collective behavior. Take superconductors, for example. At extremely low temperatures, electrons, normally solitary creatures, pair up and move in unison. This collective dance eliminates resistance, allowing electricity to flow with perfect efficiency. Another example is found in topological insulators. These materials conduct electricity on their surface, but remain insulating within. This unique property arises from the specific, stable arrangement of electrons, dictated by the topology or shape of their quantum states. These examples illustrate a key principle. Stability in quantum systems often emerges from the collective organization of its constituents, not from the properties of individual particles. Could similar principles of organization and stability be at play in the human brain?
Our brains are in constant flux. Billions of neurons fire, forming and reforming connections. Yet within this chaotic symphony of electrical activity, stable patterns emerge. These patterns represent our perceptions, thoughts, and memories. Consider the feeling of love or the memory of your first bicycle ride. These are not fleeting sensations, but enduring patterns etched into the very fabric of our neural networks. They are our mental fixed points. How do these stable patterns emerge from the ceaseless activity of the brain? Could it be that, like in quantum systems, the answer lies not in the properties of individual neurons, but in the collective organization and interaction of vast neural networks?
Mathematics provides a powerful lens, a unique perspective that allows us to see beyond the surface of things. It's a language of the universe, capable of describing everything from the smallest subatomic particles to the largest cosmic structures. Through its elegant equations and precise logic, mathematics unveils the hidden order that governs our world. It is through this lens that we can begin to understand the intricate web of connections that bind everything together. From the complex algorithms that power our technology to the fundamental laws that govern the behavior of matter, mathematics provides the framework for understanding these connections. It allows us to see patterns where others see chaos, and to find harmony in apparent disorder. Consider the Pythagorean theorem, a cornerstone of geometry, and a testament to the power of mathematical reasoning. This seemingly simple statement holds profound implications for our understanding of space and shape. A squared, representing the area of a square with side length a, plus b squared, similarly representing the area of a square with side length b, equals c squared. This equation a2 plus b2 c2 encapsulates a fundamental truth about right-angled triangles. This simple equation reveals with surprising clarity a fundamental relationship between the sides of a right-angled triangle. It demonstrates that the sum of the squares of the two shorter sides is always equal to the square of the longest side, the hypotenuse. The length of the hypotenuse, c, remains invariant, a fixed value determined by the lengths of the other two sides, regardless of the specific lengths of the other two sides, a and b. You can change the lengths of a and b, but as long as the relationship a2 plus b2 c2 holds, the length of c will remain constant. This principle of invariance, this idea that something can remain constant even as other things change, where certain properties remain constant despite changes in others, is a powerful concept that extends far beyond the realm of geometry. It is fundamental in both physics and neuroscience, providing a unifying thread that connects these seemingly disparate fields. In physics, it underpins conservation laws, the bedrock principles that govern the behavior of the universe. Like the conservation of energy, which states that energy cannot be created or destroyed, only transformed from one form to another. In neuroscience, it may underpin the stability of our perceptions and memories, allowing us to maintain a coherent sense of self and the world around us. Despite the constantly changing activity of our brains are dynamic systems, constantly rewiring themselves in response to new experiences. Yet our memories and perceptions remain remarkably stable. Just as the Pythagorean theorem reveals a hidden order in triangles, a fundamental relationship that underlies their structure, perhaps similar mathematical principles can reveal even more profound connections, the hidden order connecting the quantum world and the human mind. Could mathematics be the key to unlocking the mysteries of consciousness and bridging the gap between the physical and subjective realms?